Good morning, class. Good morning, sir. So today we're looking at functions. I gave you some homework. Let me just name this here. Okay, so we did domain range. We drew graphs within a given domain. We spoke about interval notation. Alright. Then you went on to more straight line graphs. Right. Then we drew parabolas, not so? Because also known as quadratic functions. We spoke of lines of symmetry, and then we look at interpreting those graphs, not so? Okay. Then I gave you 5 graphs to draw for homework, okay? 6 graphs. So today we're going to look at these graphs and its interpretation, okay? And then tomorrow we will look at another graph, okay? So, wa alaikum salam. So, let's look at the first one. So the first graph was, let's take us up a bit. Okay, I'm just going to delete it. You guys can just give me what the equation of the first graph was. The first graph was y equals x squared minus 1. Okay. So what you did was you drew a table, not so. Now, we can do this graphs without the table. As we did when we did straight line graphs. When we drew straight line graphs, what did we calculate? X-intercept, yes? How? By letting y equal to 0. Then we worked out the y-intercept by letting x equal to 0. So in the same light, we can draw these parabola graphs with that information. Okay? Imagine drawing a table every time we graph. Not going to make sense. Not so. So what we do is we draw the parabola graph on 4 points for grade 10. So firstly we're going to look at the shape of the graph. If the graph, just go up here. If, remember the parabola is in the form of y equals ax squared plus q. Right. Put that in the box. That's your standard form of your parabola graph, so your quadratic functions, okay? That's the standard form, which is y is equal to ax squared plus q. Alright. So, let's go down, close this door here. Alright, so when a was greater than 0, or when a was positive, let's look what happened to the graph. You go up here, you see is a positive or negative here? It's positive, not so. When a was positive, a was greater than 0, the graph looked like this. The graph was looking like it, no? If somebody looks like this, what are they doing? They're smiling. Not so. So if the a is positive, the graph is smiling. Alright. Look here. What do you notice when a is negative? When a is less than 0 or when a is negative. What do you notice now? What's the shape of the graph? The graph is a sad graph. Not so. So when a is less than 0, when a is negative, the graph is frowning or sad. If A is positive, the graph is happy. Is a happy graph. Not so. Here is again positive, smiling graph. Can you see that, people? So we make a note there that firstly we establish if the graph is firstly the shape. If A is greater than 0, the graph is smiling. Or if A is less than 0, the graph is frowning. Smiling, it also has a minimum value. It's called a minimum. Minimum. I think we spoke about that already, didn't we? Minimum, and this is your maximum value. The turning point happens at a maximum, or your turning point happens at a minimum. Can you see that, people? So that's number 1. What do we do after that? We work out our x-intercept. What do you do for x-intercept? We let y equal to 0. Number 3, we work out our y-intercept. What do you do with the y-intercept? How do you work out the y-intercept? Let x equal to 0. You guys understand? Then the 4th one is to draw or to sketch the graph. Okay, so we're going to follow those 4 steps in these 5 examples. Okay, so let's move a bit quicker so that we can get through all of them. We've got only 20 minutes in this period since you wrote this. The sounds of you wrote a good one. Right, so number 1. What's the first thing is? The shape of the graph. What can we say about the shape of this graph? It's positive. So it's happy. It's smiling. Not so. Number 2. What do we do thereafter? It's our x-intercept. What do you do for x-intercept? Let y equal to 0. So 0 is equal to x squared minus 1. So the difference of 2 squares, not so. X plus 1, x minus 1. Set each bracket equal to 0, so x equal to minus 1 or x equal to. So if you look at the graph that we have drawn, you would have seen that it goes through negative 1 and 1, not so. Right. What do we do after this? Y-intercept. What do you do for y-intercept? Let x equal to 0. So we say y is equal to 0 squared minus 1, which is negative 1. And this is now enough to draw the graph with, not so? Alright, so let's go and draw. So in our mind's eye, we know the graph is smiling. It's going to cut x at minus 1 and at 1, not so? And it's going to turn at negative 1. So we draw from this turning point. Draw going that way. Going through that point of minus 1 and 1. You guys understand? Okay? So this are the calculations on the side of your page there. Okay, so then I gave a couple of questions on the graph to answer with regards to this graph. Not so. So what was the first question I gave you? Domain. So we're just going to put here. The first one was a domain and range. Okay. Then increasing and decreasing. Né? Then you had turning point. Not so? Turning point, the coordinates of the turning point. And we must say if it's maximum or minimum, not so? And then the axis of symmetry. Axis of symmetry, the equation thereof. And then the story of f of x is equal to 0. F of x is less than and equal to 0. and f of x is more than 0. Okay, so let's look at the first one, the domain of this graph. What is the domain? All possible x values. So what's the domain of this graph? X is an element of all real numbers. Why? So it goes to negative infinity and positive infinity. All the values it includes. So x is an element of the real numbers. Range. What do you do for range? All possible y values. Does this graph exist at negative infinity? No. Where does it start existing at? Negative 1 onwards. Not so. So what do we say? Y is more than negative 1. Does the graph exist at negative 1? Yes. Next one is where's the graph? Increasing. We always read increasing and decreasing from left to right. So what happens here to the graph? Decreasing. So it's decreasing for x is less than 0. Can you see that? What happens here to the graph? It's increasing. So it's increasing for x is more than 0. Not so. So for increasing, x is more than 0. For decreasing, x is less than 0. At 0 is neither increasing nor decreasing. Okay. The next one, the turning point. What's the coordinates of the turning point? 0 and negative 1. What did we say about that? It has a minimum value of negative 1 and occurs at x equal to 0. Next one. Where is f of x equal to 0? This is the y is equal to 0 line. So it's at negative 1 or 1. Next one. Where is f of x greater than or equal to, no, less than or equal to 0? So that means to say it must be below the line. Not so. So it's all this here. So it's a continuous solution from negative 1 to 1. Can you see that? That means your x values at which that occurs. So what do we say? X is more than negative 1 but less than 1. Can you see that? Is it equal at negative 1? Yes. Is it equal at 1? Yes. Okay. And the last one, which is f of x more than 0. So in other words, where it is above the line. That's more than this part of the graph here. Not so. So we're going in that direction. So it's apart. Can you see it's apart? So your inequalities, when we write this down, will be apart. So we say x is less than negative 1 or x is more than. Alright, you guys got it? We'll go a bit faster through the next one. I want to finish all 5 graphs so you can see the variations on all these graphs. Okay. What was the equation of the next graph? Negative x squared plus 1. So firstly, we'll just write this neatly. Negative x squared plus 1. So firstly is the shape of this graph. What's the shape of this graph going to be? It's a sad graph. It has a maximum value. Number 2 is our x-intercept. What do you do for x-intercept? Then y is equal to 0. Not so? So we say 0 is equal to negative x squared plus 1. They get over the equal sign, becomes x squared is equal to 1. If I introduce square root, what must I not forget? Plus minus. So it's plus minus 1. What's the next step? Y-intercept. What do you do for y-intercept? Then x equal to 0. So y is equal to negative 0 squared plus 1, which is 1. Next is to draw the graph. Not so? So I'm going to draw the graph here. My mind's eye, the graph is frowning. It has an x-intercept of minus 1 and 1. It's turning at 1 as well. You all okay with that? There's no draw. Okay? Any confusion here, people? Any confusion? No. Oops. Alright, first things first. What is my domain? X is an element or real numbers. Range. What can you say about the range? Y is less than. Is it equal as well? So when you read it, y is less than and equal to 1. Next. Increasing. Not so. Increasing. So where's the graph increasing? Is it increasing or decreasing here? Remember, it's moving from left to right. The graph is increasing. So it's increasing for x's less than 0. What happens here? Decreasing. It's decreasing for x's more than 0. So it's increasing for x's less than 0 and it's decreasing for x's more than 0. Number 4. Turning point. What's the coordinates of the turning point? 0 and 1. What can we say about this? This graph has a maximum value of 1 and occurs at x equal to 0. I missed this one on the last question. The equation of the axis of symmetry. The axis of symmetry is basically the mirror image, not so? It's going to go down there. Why is that the axis of symmetry? Because what happens on the left of that line happens to the right of that line as well. It's basically identical on either side. Not so? So what's the equation of that axis? This is on your y-intercept. What's the equation of the y-intercept? Huh? The equation of the y-intercept is x is equal to 0. What's the equation of the x-intercept? Y is equal to 0. You see that, people? Next. That f of x greater than or less than. So where is f of x equal to 0? This is the y is equal to 0 line. Where is it equal to 0? At negative 1 and 1. F of x is less than and equal to 0. So we're going to see where the graph is. Below or above the line? Below. If it says less than, it must be below. So it's this part of the graph. Can you see that? Is it continuous or breaking solution? Is it together or apart? Apart. So your inequality, when you represent it, it will be apart. Can you see that? In other words, x must be less than negative 1. Is it equal at that point? Yes. Or x must be more than or equal to 1. And the last one again, where is f of x? We put it here. Where is f of x greater than 0? So it must be above the graph. So is that part there, not so? So it's from negative 1 to 1. This is continuous or breaking solution? Continuous. So x must be greater than negative 1. You see that that solution is together. So I write it together in the inequality form. Okay. You all okay with that? Next. What's the next equation? Y equals? Come inside. X squared plus 1. Y is equal to x squared plus 1. Yes, Michael. Morning. Allowed, come. Seafood. I don't know. It's about seafood. Okay. People? First things first. What's the shape of this graph? It's a happy graph. Sanitize? Somebody has your test? Right, it's a happy graph. Not so. Graph is smiling. Next is up. What do you do next? What do you do for x-intercept? Let y equal to 0. So 0 is equal to x squared plus 1. But if you look at this, you're going to tell yourself, but hang on. This can't be factorized. Not so. Say, okay, take it over the equal sign. Take the 1 over. So x squared is equal to minus 1. Or minus 1 is equal to x squared. Not so. Then what do we do? Square root. If we introduce square root? Plus minus. But put that in the calculator, what do you get? It's an error, not so. So if there's an error, that means to say no x-intercept or no solution. No solution means to say the graph won't cut you x-intercept. Does it make sense? So no x-intercept. Third thing, y-intercept. What do you do for y-intercept? Let x equal to 0. Not so. So y is equal to 0 squared plus 1, which is 1. Now if I draw this graph, okay, it's going to go through no x-intercept, the graph is smiling, so it's going to go through 1 there. Not so. So we don't know if the graph is going to do a broad one like that, so it's smiling, it's going to come a bit closer like that, it's going to come closer or closer. We don't know how the graph is going to do. Not so. So what we do is, we generate another point on this graph, as we did with a straight line. Not so? If we have a straight line, then we need at least 2 points to draw a straight line. Not so? So what we do is, we generate another point. How? By letting x equal. If x equal to 0, what is that? And y-intercept. What did we do when we needed to generate another point on your x-intercept? On your graph? Oh. Oh, not O. You had just said 0, now you're saying O. What do? We let x equal? To 1. 1, yes. There we go. Let x equal to 1. Now make a note there. Let x equal to 1. So if x is equal to 1, then y is equal to 1 squared plus 1, which is 2. So this coordinate is 1 and 2, which means to say the graph is going to go through 1 and a y value of 2. You guys understand? So from the turning point we draw. There we go. Okay. You need to have that point indicated on the graph as well. Okay, don't put a pencil in your eye, Michael. Don't you like your eyes? Huh? You like your eyes? Then don't put a pencil in your eye. Okay? You want to become a magician? Huh? No. People, you all okay with this? Right. Let's carry on with our lives as if nothing happened. Right. Take this out here. Sit for parabola daar. Right, first question. Eerste vraagie. First things first, domain. What do you say about the domain? Does it go negative infinity on the x and positive infinity? Yes. So domain, x is an element of all real numbers. Range. What can you say about the range? Does this graph exist at negative infinity? No. Where does it start existing at? 1. So we have a y and 1. But it must be more than. Can it be equal as well? Yes. So y is more than and equal to 1. Turning point. What's the turning point of this graph? 0 and 1. What can we say about that? This graph has a minimum value of 1 and occurs at an x value of 0. Next, increasing and decreasing. So is this part of the graph increasing or decreasing? Decreasing. So it's decreasing for x's less than 0. And then of course it will be increasing on the other side. Next, the equation of the axis of symmetry. X is equal to 0. Next, where is f of x equal to 0? Is there any part of this graph that is going through this y is equal to 0 line on the x-axis? No. So what do we say? No solution. Let's look at where is f of x less than and equal to 0. Is there any part of the graph that's below the x-axis? No. So what do we say? No solution. Next, where is f of x greater than 0? Is there any part of the graph that is above that y is equal to 0 line? Yes. Which is the whole graph. Not so? So what do we say? X is an element of real numbers. You guys understand? We got one graph left. One or two? Two. We're not going to make two graphs. But we'll try. 3 graphs. Nice. Right, what's the next equation? Y is equal to, this is number 4 now, né? Y is equal to negative
x squared minus 1.
minus 1. So if we draw this graph, this is what the graph is going to look like. So sad. So they go through minus 1. And if you let x equal to, now remember that this is going to again have no solution, not so. So what do? We let x equal to 1. Let x equal to 1. So what do? Y is equal to negative 1 squared plus minus 1, which is negative 2. So if x is 1, y is negative 2. But you guys will almost have more dots on your graph. Okay. But you're not going to do that anymore. You're going to do it like I'm doing here. Okay. You all okay with that? First things first, domain. What's the domain of this graph? X is an element of all the real numbers. What's the range? Y is less than equal to negative 1. Next, increasing, decreasing. Where's the graph increasing? X is less than. For x is less than 0, the graph is increasing. Did you see that before? So x is less than 0. Where is it decreasing? X is more than 0. Next one. Turning point. What's the coordinates of the turning point? 0 and negative 1. This graph has a maximum value of negative 1 and occurs at x equal to 0. The equation of the axis of symmetry. X is equal to 0. Where is f of x equal to 0? See, any part of this graph is going through the x-axis or the y is equal to 0 line. No. So what do I write? No solution. Okay. Then, where's f of x? Less than or equal to 0. What do you notice about? Is there any part of this graph under the y is equal to 0 line? Yes, the whole graph. So what do I write? X is an element of real numbers. Where's f of x more than 0? Nothing. No solution. Okay. Do you guys understand?
Yes.
And the other two I'm sure you guys can do on your own. Not so? Okay. Must I do it?
Yes.
Oh my word.
Just the last one.
Okay, this is the last one. The last, that's not everything. Come on now. Okay, let's just do it. What's the equation?
Negative 2x squared
Y is equal to negative 2x squared
plus 18.
plus 18. Right, so first the shape the graph is from. Not so. Then x-intercept. What do you do for x-intercept? let y equal to 0. So 0 is equal to negative 2x squared plus 18. You take it over the equal sign. So 2x squared is equal to 18 divided by 2. So x squared is equal to 9. Square root, don't forget, plus minus. So x equal to plus minus 3. Y-intercept, what do you do for y-intercept? Get x equal to 0. So y is equal to negative 2 times 0 squared plus 18, which gives you an answer of 18. So this is enough to draw the graph, not so. The graph is crowning. There's an x value of minus 3 and 3. It's turning at 18. There we go. Can you see that, people? Take this off here. So let's look at number 1, the domain. X is the element of all real numbers. As it goes negative infinity, positive infinity. The range. Y is? What's the range of all possible y value? Does this graph exist at negative infinity? Huh? No. Where is it existing at? It exists at negative infinity. That's why the arrows are there. So this graph exists at negative infinity, yes or no? Yes. Where does it stop existing at? 80. So we got y at 80. Well, it must be less than or equal to 80. The third thing was the increasing and decreasing. So the graph is increasing for x is less than 0. It's increasing for x is more than 0. Number 4, turning point. What's the coordinates of the turning point? 0 and 80. This graph will have a maximum value of 18 and occurs at x equal to 0. Number 5, axis of symmetry, x is equal to 0. Number 6, where is f of x equal to 0? Equal to 0 at negative 3 and at 3. Okay. Number 7, where is f of x less than or equal to 0? Is for x is less than negative 3 and equal, or x is more than negative 3, and equal. Okay? This is 3, no? Where is f of x more than 0? As you can see, is this part of the graph here. It's from negative 3 to 3. So x is greater than negative 3, but it's not. You always write the smaller one on the left hand side. Right, you guys understand? Now for homework, I would like you guys to do you see exercise 7.5, exercise 7.5 number 2. Answer exercise 7.5 number 2. Again, you're going to draw the graph, you're going to look at that perpendicular graphs. Okay. I know you guys are saying that is too little work, but we will just... Right, so it's exercise 7.5, so your homework is exercise 7.5 number 2, and then you do for me exercise 8.3 number 1. In exercise 8.3 number 1 on page 170, now the first one deals with there's 6 sums there, dealing with the parabola graphs. For those graphs, I want you to answer domain, range, increasing, decreasing, all of those questions, okay, as we did before. But I want you also to use the intercept method that I showed you, okay, that I showed you today. People enjoy this every day. Good morning, class. Salam, how are you?
Alhamdulillah, you must give us 2 packets of water, please.
2.
Yeah, bismillah.
Okay. This is exercise 7.5, number 2. Okay. That's up until E. F to the end. So it was 8.3. Okay,